The Type 052D destroyer is a class of guided missile destroyers being deployed by the Chinese People's Liberation Army Navy Surface Force. Currently it is being built at 2 different Chinese shipyards. After the Type 052C destroyer, 2 new hulls were spotted under construction at Changxingdao-Jiangnan Shipyard in August 2012. According to the picture, they were armed with a new 130mm main gun and new AESA radar system. Altogether 6 vessels of this class are now fitting out or under construction, with at least a further 2 on order or planned, 3 vessels on sea trial and 2 vessels active. Design. The layout of the Type 052D is similar to the earlier Type 052C, but the superstructure of the Type 052D slopes inward at a greater angle, providing reduced radar cross-section. The helicopter hangar on the Type 052D is moved to the center, as opposed to being on the left like on the Type 052C. A pair of enclosed boat raft launching systems similar to the Type 054A frigate is added, with 1 on each side of the helicopter hangar. The Type 517H AVHF radar mast is moved toward the stern of the ship. There are several mounting sites for a new single-barrel 30mm stealthy gun mount that is fully automated. The addition of this small-caliber weapon is presumably for the need to counter non-conventional threats such as potential terrorist attacks and anti-piracy operations, but as of the end of 2012, no 30mm gun mounts have been observed to be installed on the hull yet. Due to the greater angle of superstructure slope, more space was made available for the active phased array radar, which first appeared in June 2012 on board plan weaponry trial ship Bisheng. It is believed that this new APA is a development of Type 348 radar mounted on the Type 052C. One of the main differences is that the size of the new array is larger, so presumably there are more transceivers on each array. Another obvious difference is that the curvature resulted in the need for air circulation on earlier APA on Type 052C is gone, so it is believed that the new APA on Type 052D must have adopted a pure liquid cooling system instead of the mixed air and liquid cooling system on earlier APA on board Type 052C. Vertical launching system equals, the Type 052D has a brand new vertical launching system for surface-to-air missiles, cruise missiles, anti-submarine missiles, and anti-ship missiles, and is capable of quad-packing missiles and cold launch. It is the 3rd type of Chinese VLS system identified, after the circular version of VLS on Type 052C destroyer and the rectangular version on Type 054A frigate. The VLS system on Type 052D differs from that on Type 052C. The circular-shaped VLS system on Type 052C is replaced by the VLS with rectangular cells on Type 052D. Moreover, this box-like VLS looks different from the VLS system of Type 054A. Photos show that Type 052D's VLS system does not contain the shared exhaust vents between the rows of launching tubes, which is the common feature of Type 054A's VLS. Instead, the VLS on Type 052D looks more similar to the American Mk-41 VLS, but without obvious indication of exhausts. The lack of exhaust vents in the leaked photos leads to some Chinese internet forums postulating the cold launch method is adopted on Type 052D, but such claims cannot be confirmed by independent or official sources. Other sources on Chinese internet forums state that the difference between the VLS on Type 052D and VLS on Type 054A is simply a rearrangement of exhaust to a different location, and Type 052D is still utilizing the hot launch method like Type 054A, but used a more advanced method of concentric canister launch system, first pioneered by USA in the mid-1990 for Mk-41 VLS upgrade. This second claim appears more probable than the cold launch claims, because official Chinese sources have confirmed the existence of CCL-VLS developmental program headed by the School of Mechatronics Engineering of Beijing Institute of Technology, and various research papers have been publicized, such as the effect of the flow mechanism and annular size of CCL and others. It is reported that chief designers of Chinese CCL-VLS included Professor Yuan Xianfeng, Professor Miao Peiyun and Professor Liang Shaiji. When using CCL method, The flame produced in hot launch is diverted through the space between the inner and outer canisters within each individual VLS cell, so no specially dedicated exhaust shared by several cells are needed, thus similar to how British vertical-launched Seawolf missile operates, and this is why CCL-VLS can be mistaken for cold launch due to the lack of dedicated exhaust sandwiched between two rows of cells in traditional VLS, while in reality, the exhaust of CCL-VLS is within each individual cell. What is also confirmed by semi-official sources in China is that the VLS on Type 052D is built to GJB 5860-2006 standard, so that different types of missiles can be launched by a single launching system. According to some of the publicized examples of GJB 5860-2006 requirement, there are three types of VLS that differs in length, 9 meter, 7 meter and 3.3 meter respectively, but the diameter is same for all, 850 mm maximum, with each launching tube filled with either dry air or nitrogen inside, and with higher internal pressure similar to U.S. Navy's Mk-41. A launching module includes 8 launching tubes, and each tube can house 1 to 4 missiles. Each launching module has a launching control unit, which can simultaneously launch up to 4 missiles of different kind. The launching control unit must have built-in test diagnostic function. These publicized portions of GJB 5860-2006 are surprisingly similar to that of Mk-41 VLS, which prompt some Chinese internet sources to claim that there are potential future export of such systems so that it has to comply to Mk-41 VLS, the most widely used VLS in the world. Naval gun Another improvement of the Type 052D is that the Type HPJ-87 100mm gun on the Type 052C is replaced by a new single-barrel 130mm gun, designated as the Type HPJ-38. Data link Sources on the Chinese internet have stated that Type 052D is equipped with the newest Chinese data link which has just completed national certification in June 2012 and publicized by the end of year. Designated as JSIDLS, this is the Chinese equivalent of Link 16, a significant improvement of earlier HN900 which is the Chinese equivalent of Link 11/TADILA installed on Type 052C. The general designer of JSIDLS is Major General Wang Jiangxi, who was the also head of the Research Institute of the People's Liberation Army General Staff Department assigned as primary contractor of JSIDLS. More than 300 establishments and 8,000 people were involved in the development of JSIDLS, and it won state science and technology prizes after completion. Chinese Aegis Chinese media informally designate the Type 052D as Xung-as Hendon/ACNC 3/4, which means Chinese Aegis. The new destroyer is equipped with a flat-array AESA radar, a 64-cell VLS and modern long-range anti-air missiles. The destroyer is expected to have capabilities similar to those of a U.S. Navy Arleigh Burke-class destroyer. There is speculation that the radar systems on Type 052D destroyers are able to detect stealth fighter aircraft, particularly the American F-35 Lightning II, especially if the Type 346 radar is an S-band radar like the American Spy-1 radar. Tactical stealth fighters are optimized to be undetectable from higher frequency radar bands such the C, X, and Q, but features like the tail fin may make it susceptible to lower S or L band frequencies. Depending on the distance between the ship and aircraft and the strength of the return of the omnidirectional signal, a target may not be picked up at a tactically significant distance since L-band and most S-bands have resolution cells that cannot generate quality targets for weapons tracking. However, the Spy-1 and air and missile defense radar operate in higher frequency portions of the S-band and are able to generate weapons quality tracks, so Chinese systems could be similar. China is also suspected to be reducing the size of the large radar resolution cells by connecting multiple low-frequency radars through high-speed data networks, which has the potential to refine resolution enough for tracking a missile to the target. Ships of class. See also, Arleigh Burke-class destroyer. United States, Kolkata-class destroyer. India, Konga-class destroyer. Japanese, Artigo-class destroyer. Japanese, Sejong the Great class destroyer. Korean, an Lvaro de Baza N class frigate. Spanish, Hobart class destroyer. Australian, Type 45 destroyer. United Kingdom. References. External links, 1, 2.